Alright, a little talking about complex numbers. But don't worry, we're going to make it easy and not complex. Complex is just the name of it. And we're going to talk a little bit about the numbers that we know about so far. You started talking about whole numbers and natural numbers when you first started doing math. And then they brought up fractions, right? Well, the fancy word for that is rational numbers. These are anything like fractions, anything that can be written, we say, as a p or a q, where they're integers. And so what falls into this is also 0.25, because that could be written as 1/4. So decimals are in here. Or 0.3, repeating decimals. That can be written as a 1/3. Irrational numbers, things that can't be written as fractions. And you know what? Even the number 1 is in here, because 1 could be written as a fraction, or 5. So it includes a lot. Irrational numbers, things like the square root of 2. Non-repeating decimals. Things like pi, things that can't be written as fractions. Together, these numbers equal the real number line. Everything that you draw on the number line from negative infinity to positive infinity, anything that you draw on the real number line anyways. Think about it like that. Real number line. Today we're going to talk about imaginary numbers. Imaginary. Now, we have to get over the name because it's a really bad name. Because they're real. They're just, we can't call them real because this is what we call the other set of numbers. And so what these are 5i. They're outside the real numbers, non-real. And so that's really what a better word for it is, non-real, but they call them imaginary. And here's where they come from. All throughout your math career so far, they've told you that you can't take the square root of a negative. As soon as you can take the square root of 16 and say that's 4, but if you had the square root of negative 16, you can't do it. You've been told that it can't be done because nothing times itself is equal to negative 16. Today, the world changes. So, square root of negative 1 is I, one imaginary unit. Again, bad word because we're saying imaginary. It's not imaginary. Notice that if you square both sides, I squared, and if you square root the square root, you get negative 1. So I squared is equal to negative 1. Very important to know that. Very important to know I is equal to the square root of negative 1. Typically we go from here to here, so don't let it scare you off. So, square root of negative r is equal to square root of negative 1 times the square root of r. And so square root of negative 1 is I. So back to our square root of negative 16. That's the square root of negative 1 times the square root of 16. So that's equal to I times 4, or we'd much rather write it as 4i. And so that's what we're going to practice today, getting used to where that square root of negative 1 goes and what happens to it. So if I squared is equal to negative 1, if I cube the I cubed is kind of like I squared times I, so that's kind of like negative 1 times I, so negative I. I to the 4th is kind of like I squared, or let's say I cubed times I. Actually, I like I squared times I squared better. I squared times I squared. So that's negative 1 times negative 1. So that's equal to a positive 1. And I to the 5th is I to the 4th times I. Well, I to the 4th we just said was equal to 1. And 1 times I is I. And so what we do is we start a whole cycle. It goes in cycles of 4, where it's I, negative 1, negative I, 1. I, negative 1, negative I, 1. And such goes the cycle. It's just kind of a fun problem. we could go, say, I to the 80th power. And because I to the 80 is a multiple of 4, that means I to the 80th is 1. So, and we can just mess around with that. So, x squared equals negative 36. When you take the square root of both sides, we have to remember plus or minus. And the square root of negative 36 is kind of like 36 times the square root of negative 1. And so that's going to be plus or minus 6. Square root of negative 1 is I. And so we get 2 answers. Square root of 4 is 2. Square root of negative 9 is kind of like the square root of negative, or square root of 9 times square root of negative 1. So you get 2 times 3 times I, or 6I. These, you cannot multiply these together first. We have to reduce the radicals and take care that they're negative first, because multiplying the roots is just not a property that can be done. And so we have to really, let's make this I square root of negative 1 times the square root of 5, which would be I root 5. And then square root of the negative, and there's a 25 in there if you want, and so square root of 25 times the square root of 3. Think about reducing this radical. And so we have an I, and then square root of 25 is 5, and we have the square root of 3. So we have 5I squared, because I times I, and the root 3. Now, I squared is equal to negative 1, and that's considered more simplified, so we want to take care of that. So we get negative 5 root 3. Now, had you multiplied these together, you would have gotten a positive, and you would not have ended up with the negative, and that's why it's so essential to take care of the negative ones and make them i's first. So, same way, let's take care of these. So we get 4 times the square root of negative 1 times 9 times 2. Let's think about reducing this radical. Look for the perfect square in it. So you have the negative 1, you have the square root of 4, and you have the square root of 3. So 4 times 3, this is going to give us I, this is going to give us 3, this is going to give us I, this is going to give us 2. And so then we have 4I times 3, and so let's just say 4 times 3 is 12. I root 2, and 2I root 2. Root 3, sorry. So I divided by I is 1. 12 divided by 2 is 6. So we have 6 root 2 over 3. And what we want to do now is rationalize the denominator when we practice this in the last stuff. And so multiply by root 3 over root 3. And you get 6 root 6, 2 times 3 is 6, over root 9, which is really 3. And 6 divided by 3 is 2 root 6. Let's try another. 15 over the square root of negative 1. 32 is made up of 16 and 2. It's also got 4 and 8 in it, but 16 is the biggest perfect square, so I'm going to say the square root of 16 and the square root of 2. So I get 15, and I get 4, and I get I, and I get root 2. Now, I want to get rid of the I in the denominator, and I want to get rid of the root 2 in the denominator. So I'm going to multiply by I root 2. If I multiply with the 4 as well, there's nothing wrong with it. There'll just be more to simplify in the end. And so I get 15I root 2. And then on the bottom I get 4I squared. And then square root of 2 times square root of 2 is the square root of 4, which is really just 2. So 15I root 2. I squared is negative 1, and 4 times 2 is 8. So I can make this negative 8, or you can just make it a negative 15I root 2 over 8. And there you have it. So adding works the same way. You only want to add like terms. And so we want to reduce square root of negative 1 times the square root of 9 times the square root of x squared. So you get 3, you get x, you get I, plus the square root of negative 1, square root of x squared, plus x times I. So 4xi and really 1xi, 3xi, and 1xi make 4xi's. And there we have it. Again, square root of negative 1 leaves the 6y alone, times the square root of negative 1 and the 2y. So we get square root of negative 1 is I root 6y times I root 2y. So you get I squared times 6 times 2 is 12, and y times y is y squared. And we get negative 1, square root of 12, so that's the 4 and the 3. And so I'm going to pull out a 2, leave in the 3, and I'm going to pull out the y. And the 3 was left in, remember? So we get negative 2y root 3. And that's what those roots look like. So a little more solving ones here. If I subtract 25, I get 4x squared equals negative 2. If I divide by 4, I get x squared equals negative 2/4, or negative 1/2. And then I take the square root. Gasp, we can't take the square root of a negative, but yes we can. We just learned how. Plus or minus the square root of negative 1/2. So I'm going to split that up into the square root of negative 1 over the square root of 2, which square root of negative 1 is plus or minus I over root 2. And so now we have to just rationalize root 2 over root 2, because what that gives you is plus or minus I root 2 over 2. Some people will write the I in front, some people will write it as root 2 over 2 with the I like that, and that's probably more acceptable because it's BI. So there you have it. Let's do it with this one. Subtract the 19, so 2x squared equals negative 16. So x squared equals negative 8 after you divide by 2. And then you take the square root of both sides, x equals plus or minus. Don't forget the plus or minus, it's very important. Square root of 8 is made up of the square root of negative 1, square root of 4, square root of 2. And you get plus or minus. The square root of 4 is 2, the square root of negative 1 is I, and the square root of 2 is just in there. And so you can write it like that, or sometimes people may write it as 2 root 2 I. And that works as well. So there you have it. Your introduction to imaginary numbers.